Today we are going to solve an amazing problem, magnets. Okay, so magnets. What is this problem is stating? Basically, the problem statement is too long, so I will explain you the whole problem statement. Then we will move to the solution. Okay, so basically, firstly we are provided two numbers, 5 and 6. Okay, 5 represents number of rows, 6 represents number of columns. I'm talking about this example. Okay, so we are having two arrays. Now we have created, we are provided with a character array of size 5 comma 6. That means 5 number of rows. You can see 1 2 3 4 5 6 number of columns. Okay, now in this character array we are having some letters L, R, T and B. These are the 4 letters which are filled in this character array, where L represents left, R represents right, T represents top, and B represents, just guess, yeah, bottom. Easy. Okay, now what these represent basically, as the name of the problem suggests, magnets. So what we have to do, we have to create a same character array of same configuration, 5 comma 6. That means 5 number of rows. That means 1 2 3 4 5 6 1 2 3 4 5. Okay, 5 comma 6 we have to create another character array, and then we have to put magnets into this array. We have to put magnets. Okay, so firstly let's discuss what is magnet. I don't know what is magnet. So basically, magnet attracts another magnet. Magnet is simply, you can say, this is a magnet. This is a magnet which is having two poles, plus and minus. Basically, in a magnet, two ends of a magnet shows two different poles. Let's say if this is positive, this will be negative. Okay, these are the two poles. Now, one of the property of magnet is, let's say if I am putting another magnet in front of it with negative pole, just pointing to the negative pole of previous one, like this. Okay, so in this case these two magnets will repel each other. These two magnets will make force towards each other. That means they will repel each other. Okay, so in this case we have to manage this case. Whenever we are putting magnets into our array, what we have to do, we have to check whether these two magnets are repelling each other. If they are repelling, then we cannot put those magnets into that configuration. Okay, basically, in general way, if I am saying that you have to put a magnet into this array. Okay, so what are the ways? Either you can put your magnet in vertical direction or in horizontal direction. Okay, in vertical direction also you are having two choices. What are the choices? Either you can put plus minus, or you can put minus plus. In horizontal direction you are having two choices, plus minus and minus plus. Okay, so these are the choices. Normally these are the choices. Okay, now let's come back to our question statement. This is the discussion about magnet. Okay, this is the discussion about magnet. No problem. Now let's discuss about our question. Basically, we are having a character array in which LRTB is present. LR, this is a pair. Whenever we are concluding L, whenever we are taking L into consideration, we have to take R also into consideration, because LR is a pair. LR is a pair, and what this pair suggests, that we have to put a magnet. It's your choice whether you want to put or not. There is always a choice that I can put a magnet or not put a magnet. Okay, so if I am putting, then this LR is suggesting me that I can only put the magnet into horizontal direction. That means basically, if I got L, okay, I see that L is present. So definitely there is a 100% chance that R is going to be present on the next index. So LR is a pair. Okay, so what I will do, I am having two choices. Either I can put plus minus, so this will be a magnet. Okay, and another choice, I can put minus plus. So these are the two choices in which I can put a magnet on the same index, same similar index. That means if this is 0 0, this is 0 0, so I have to put 0 0 here, and I have to put a magnet on this index. Okay, so if this is LR, so I have to do in this scenario, let's say if it is T, if it is T. Then what I have to do? Basically, T represents top and B represents bottom. So exactly similar as LR is a pair, left right is a pair, TB is also a pair. Whenever you will get T, 100% you will get a B also just below it, because TB will be put in this way, vertical direction. LR is going to be put a magnet in horizontal direction, and TB will put a magnet into a vertical direction. Okay, no problem. Now, when I'm getting T, so what are the choices? Either I can put plus minus or minus plus. So let's say here I got T. So I will find the exactly same index, that is this one. Now I am having two choices, plus minus or second choice is minus plus. Minus plus. So these are the two choices in which I can put a magnet. And similarly, I have to check all the cases. Now basically, if I am saying that this is the only question. Oh, wait. Yeah. This is the problem statement, that you have to simply put magnets into this new character array in such a way that they should not repel each other. Okay, if this is the only problem statement, then this is very easy. Basically, we are having two choices. First choice, either I can put plus minus plus, or nothing. Nothing means initially in this character array, all the indexes are filled with capital X or cross. Okay, all the indexes are filled with X. Okay, initially. So if you are not putting anything, if you are not putting any magnet on that index, so basically that index will remain empty. No problem. So if I just say that this is the only question, that I am providing you a character array in which LRTB is present. LR represents that you have to put the magnet from left to right direction, and TB represents that you have to put the magnet in top to bottom direction. Okay, if this is the only problem statement, then you are having simply three choices. At every index you will make this choice. Easy. But no, we are having some more conditions, some more constraints, which are these four arrays. This is top, this is left, this is right, and this is bottom. These are the four arrays which are also provided in input. Okay, so what these four arrays represent, this top is representing that this is 0, 1, 2, 3, 4, 5. Okay, this top is representing that at first column, that means in this first column, this column is similar to this column. Okay, so when I am talking about index 1, so index 1 represents, that means top of 1 represents that in one column, in first column of our main character array. Let's say it is ARR. So in the first column of our character array, the total number of plus symbol can be minus 1. Okay, so we have taken minus 1. Okay, so leave it. I'm talking about 2. I'm talking about this case. Okay, I have taken the wrong example. We will discuss about minus 1 also. Okay, but after discussing 2, we will discuss minus 1, what minus 1 is representing. No problem. Okay, so basically I'm talking about 2. Okay, this is the third index. So top of 3 represents that at most top of 3 number of plus symbol can be placed into ARR of I'm not talking about row, column 3. Understood? That means in this column, the total number of plus should be equals to, because this is the condition that it should not exceed. But in the final case, when we are checking whether this array is correct or not, in this case we have to check whether the total number of plus present in this column, is equals to top of that index, because index value is 3. I'm talking about index equals to 3. Okay, so top of 3 should be equals to total number of plus present in array index 3, array column 3. Okay, so let's talk about 1 also. Let's talk about 1. What 1 is representing? 1 is representing that in this column, total number of plus should be equals to 1. should be equals to 1. Okay, this one represents that in this column total number of plus should be equals to 1. Now what this minus 1 is representing, minus 1 represents that you can put any number of plus into this column. Minus 1 is very calm. He is saying that you can put any number of plus into this column, no problem. Now what left is representing, our top and left are discussing, are taking plus into consideration. Okay, and bottom and right are taking minus symbol into consideration. Okay, now what left is representing, left represents that in this row, I'm talking about this column. Okay, this row, so what this left of 0 is represents that at 0th row the total number of plus should be equals to 2. Okay, similar for 3, minus 1 represents that you can put any number of plus into this row. What this 2 is representing, this 2 represents that total number of minus present in this column should be equals to 2. Understood? So these array are you can say these array are constraints. These array are constraints that we cannot put more number of plus or minus than these numbers. Okay, so this is the problem statement. Basically, you have to create a character array. You have to put magnets. Into this array, and the configuration of that magnet will be told by this L and T. L represents you have to put in horizontal direction. T represents you have to put in vertical direction. Okay. After that, the number of plus and minus in a particular row and column is represented by top, left, bottom, and right. The number should not exceed their values. This is the constraint. Okay, no problem. So this is the problem statement, and this is the output. Let's put it here. Basically, you can see that this will hold true. For every value. I'm going to take only one example. Basically, for this. Okay. So bottom of 4. Bottom of 4 is representing 0, 1, 2, 3, 4, and 5. Okay. Bottom of 5 is equals to 3, which represents that at the fifth column, total number of minus is equals to 3. So let's check. 1, 2, 3. Yeah, minus, the total count of minus is 3. It's correct. Now take one more example. Let's say this one. So right of 1. Okay. So this represents that 0, 1, 2, 3. So at third column, at third row, total number of minus should be equals to 1 at third row. So 0, 1, 2, 3. At third row, total number of minus should be equals to 1. So this is holding true. Okay. So you have to create this array. This is the array. You have to create this. Okay. Now, let's talk about generally how we are going to do this in very general, because this question is lengthy but not hard. Okay. So basically, what are the choices at any index you are standing? And at any index you are standing, what are the choices? Firstly, you will check whether L is present or T is present. This is the first condition. You will check whether L is present or T is present. Okay. Let's say I am saying L is present. Okay. So you are having two choices. Either you can put plus minus or minus plus. Okay. These are the two configurations, plus minus and minus plus. Okay. Now, how you will decide whether this configuration is right? Basically, you have to check now whether you can put plus on that index, minus on that index or not, and minus and plus on that index or not. So basically, let's say we are having this array. Okay, this is our answer array. 1, 2, 3, 4, 5. Okay, let's say here plus is present, here minus is present. Okay, and you got L. So you are having two choices. Currently you are here, and you got L. What are the choices? You can put plus minus, you can put minus plus. Okay, so let's say I decided I will put minus plus. So can you tell me whether this configuration is right or wrong? Please tell me. Basically, this configuration is wrong. Why? Because these two magnets, this is the first magnet, this is the second magnet. These two magnets are repelling each other. So this configuration is wrong. So the only choice which we have is we have to put plus here and minus here. This is the only choice. So whenever we are putting some magnets, we have to check whether is there any neighbor same symbol value. Neighbor same value means, let's say if I'm talking about this, I want to put plus here. I want to put plus here. Okay. So what are the choices? I have to check whether plus is present here, here, or here. I have to check three cases when basically I want to put plus here. I want to put plus here. Okay. So if plus is present here, I cannot put it. If plus is present here, then also this is the wrong place. If plus is present here, then also this is the wrong place. So I have to check three conditions in which I can put a plus here, or exactly same thing for negative also. Okay. So basically what I am saying that you have to check whether you can put basically first you have to check whether L is present or T is present. This is the first case. Okay. Second, you are having choices. You can put plus minus, you can put minus plus. Okay. Third, you have to choose, you have to decide whether you can put this or not. For minus also you can put this or not. These are the cases. Firstly, for minus, you have to check whether I am getting repelled by any of the same symbol. If this condition is true, that means I cannot put minus on that position. Okay. So we will discuss more about this. But firstly, let's get quick overview about indexing. How I am going to see whether L is present, R is present. So what I will do, I will traverse. This is ARR. This is ARR, and this is answer. So I am having two character 2D array. Okay. So I will traverse array from left to right. I will traverse this array from left to right. That means from 0, 0 to 0, 1 to 0, 2 and so on. Okay. And when I will reach 0, 6, which doesn't exist, then I will switch to 1, 0. Okay. So we will see the code, but I am collecting all the tools to build this code. Okay. I am collecting all the tools. This is one of the tool. This is also one of the tool. Okay. So I am collecting all the tools. I am guessing what are the possibilities. Okay. Now let's see. Let's say, yeah, I'm talking about L. Okay, I'm talking about L. So let's say I'm present at index 0, 0, 0 row, 0 column. Okay. Now I'm talking about L. Okay, I'm not talking about T because L is easy to understand. If you understood L, then T is also understandable. Okay. I'm standing at 0, 0. Let's say I got L, and I am having three choices. I'm having three choices. What is plus minus? Okay, minus plus. That's okay, and nothing. That means cross. Okay. So if plus minus, if I'm choosing that I will put magnet in plus minus configuration. So next, at what index should I check whether basically in recursion column you have to pass row and column. If you see here, you have to pass row and column. Okay. So at this point I decided that I will put plus here and minus here. At row column I will put plus. At row column plus 1 I will put minus. So this is my choice. I put plus and minus. Now at what index should I jump? At what index should I jump, or at what index should I make the next recursion call? Just guess the answer. Basically the answer is 0, 2. 0, 2. Why 0, 2? Because let's say I am at 0, 0. So this is row, this is column. Okay. I have taken decision for row column. That is, I will put plus here. Okay. I have taken decision for 0, 1 also. Okay. Row column plus 1. 0 plus 1 is 1. So I am putting minus here. So I have taken decision for 0, 0 and 0, 1. Where 0, 0 is L, 0, 1 is R. That's why I said in the starting that LR is taken as the pair. TB is taken as a pair. Understood? So when we are taking LR as a pair, so I am taking decision for R also and L also. That's why I am moving to column plus 2. Column plus 2 because I have taken decision for 0, 1. Now I should move to 0, 2. Understood? So my next recursion call will be 0, 2 for row equals to 0, column equals to 2. Okay. In this case, minus plus. Exactly same. I am taking decision for 0, 0 as minus, for 0, 1 as plus. Now the next decision should be made for 0 comma 2. Okay, if I'm deciding that I will not put any magnet on this index, that means currently this index is empty. Okay, and at row equals to 0, column equals to 0, I'm deciding that I will not put any magnet on this index. So what will be the next choice? I will move to column plus 1. I will move to column plus 1. Easy now. Basically, if I'm deciding that I will not put any magnet on this index, so there is a clear choice that I have to move to the next index. So next index is column plus 1, because I am moving left to right. Left to right. Okay, this is my movement. Understood? Now, for 0 2 also, I am having three choices. Basically, three choices. I can put plus minus. Okay, let me remove this. I need some space. Okay, let's move this. Yeah, I can put plus minus. After that, the call will be for 0 4. Okay, I can put minus plus. Okay, the call will be for 0 4, and I can put nothing. I decided that I will not put anything, so the call will be for 0 3. Okay, so just tell me whether this case is possible or not. Just tell me whether this case is possible or not. Just analyze it, because initially I put plus minus, so this is the case, plus minus. Now I move to 0 comma 2. Here I am deciding whether I can put plus minus and minus plus. So if I am putting minus plus here, this is the wrong case, because these two magnets are repelling each other. So I have to remove this case. I have to, you can say, avoid this case. Avoid. So to avoid, what I will do, I will create a if safe function. If safe function. That function will check. All the things. Okay. All the things means whether any other magnet is repelling. This is the first choice. Second, whether when I will put plus here, let's say I'm talking about this column. Okay, here the value of top of 0 is 2. Top of 0, this is the 0th column, and top of 0 equals to 2, where 2 represents that in this column at most 2 plus can be held, 2 plus can be placed. Okay, so let's say plus is here, minus is here, plus is here, minus is here, and I'm taking decision for this row, this column. Okay, so what can I do? I have to check whether total number of plus present in this column, total number of plus present in this column, okay, is lesser than top of 0. This should be the condition. Whenever I am putting plus, I have to decide that total number of plus present in this column should be less than top of 0. If it is greater than or equals to 2, that means there already presents 2 plus in this column. In this case, 2 plus is already present. 2 plus, this is the first plus, this is second. So I cannot put any more plus in this column. Why? Because the limit is 2. And I am also demanding that I want to put plus here. I want to check whether I can put plus here. So I have to simply return false, that no, you cannot put, because I am already having 2 plus in my column. Okay, so these are the conditions which we have to check. Okay, let's move to code, because code will provide us more clarity. Okay, so basically the code is very lengthy, so you have to keep patience. Okay, so basically what are the choices? Firstly, I have to check whether L is present or T is present. So if array of row column is equals to T, okay, or simply L. If L is present, then I have to do something. If T is present, in that case also I have to do some. T is present. Okay, so in this case also, if array of row column is equals to L, so in that case, what are the choices? I can put plus minus or minus plus. So what I will check whether putting plus minus is safe or not. I have to check now. I decided that I will put plus minus here, but before putting, I have to decide whether they are safe or not. So I will create a function is safe. Okay, I will create it. In this, what are the arguments should I pass? Answer, top, left, right, bottom, and row, column, and which symbol, which sign you want to put on that index. So I'm currently dealing with plus minus, so I want to put plus here, and I have to check for minus also. Is safe. Answer: top, left, right, bottom. Okay. Yeah, after that, row, column, plus 1. Because if I'm putting plus on row column, then the second choice is I have to put minus on row column plus 1, because this is L, left to right. Okay. Now here I want to put minus. Okay. So if it is returning me true, that means I can put plus minus here. So in that case, I have to put plus minus. So row, column should be equals to plus. Very easy. Answer of row, column should be equals to minus. Very easy. Okay. After that, I have to make call when because I am putting row and column. I am putting plus and minus on row and column. So after that, I have to make call. If solution of array, top, left, exactly same. Okay. Right, bottom. After that, answer row and column plus 1, column plus 2. Why column plus 2? Because I have made decision for row, column plus 1. So I have made decision for column also, column plus 1 also. Then I will move to column plus 2. Okay. Now what this will return me, you can see the type is bool. What this will return me, this will tell me whether I found the answer or not. This bool is saying that I found the answer or I didn't find the answer. So if I found the answer, in that case, I have to simply return true, that yeah, I found the answer. If I don't found the answer, in that case, I have to change the original values. That means capital X, answer of row, column plus 1 equals to capital X. Okay. Now copy this code for minus plus. This is plus minus configuration. Now I am doing exactly same work for minus plus configuration. Okay, exactly same code. After that, okay, so I have created all the choices when the value of array, row, column is L. Now let's say if the value is T, in that case, just copy this code again, because the code is very lengthy now. So just copy it so that it will reduce our time. Okay. Now in this case, what are the choices? I have to make choice for row, column and row plus 1 column. Previously what we are doing row, column plus 1. In this case, row plus 1 and column. Okay. So row, column equals to plus, row plus 1 and minus. Okay. Here what we have to do, row plus 1 and okay, here column plus 1. Okay, so I made a mistake. Column plus 1, no problem. Column plus 1. Okay. Now what you have to do, basically row plus 1, I am putting plus on row column, and row plus 1 column is putted by minus 1. After that, I am making call for column plus 1, and then row, column, row plus 1 and column. Okay, exactly same code. After that, I am putting minus here and plus here, so I have to remove 1 from this side, plus 1 put here. After that, right here, row plus 1, exactly same thing, column plus 1, row plus 1 and remove column plus 1. Okay, exactly same code. What I am doing basically, okay, for L I am making two choices, plus minus, minus plus. Okay, if this configuration is true, that means row, column equals to plus, row, column plus 1 equals to minus. Okay, so I am putting plus minus on that particular index, and I am making call for column plus 2. Easy. Let's say it is T, so exactly same, plus minus, minus plus, no problem. So I am putting row, column equals to plus, row plus 1, column equals to minus. Okay, and I am making call for column plus 1. Why column plus 1? Because in this case I am moving horizontally. So initially when L was present, I made choice for column also, column plus 1 also. But for TB, I am making choice for same column but different rows. Understand this difference? Basically, in T means top to down, top to bottom. I am making decision for same column but different rows. And in L, I am making choice for different columns but same row. So I am making choice for column and column plus 1 also. That's why I am moving to column plus 2. Okay. But in top, I am making decision for column and row plus 1 and column. So I have made the decision for column. Then I should move to column plus 1 now. That's why I am moving to column plus 1. Okay, column plus 1. Yes, column plus 1. Understood? So now these are the two choices, whether L is present, T is present. Now if I don't want to put anything, so bool not taken. Okay, in this case I will simply move to the next column. I am not putting anything on any index. So left, right, bottom, row, column plus 1. Okay, and here after bottom, answer. Okay, so array here. Let's see what are the arguments. Basically, array top, left, right, bottom, answer, row and column. So answer, row plus column. Okay, if this is returning me true, that means I found the answer. In that case, I have to simply return true. Else, or simply without else, I have to simply return false. Understood? Basically, I am making two choices, plus minus, minus plus. Third choice is I am not going to put anything. In this case, I just explained that choice. Okay. Now when I will hit the base case, just think about it. When I am going to hit the base case, basically, I am moving horizontally, left to right. I am moving horizontally. That means, okay, let's take boulder. Okay, so I am moving horizontally from this side to this side, So whenever my index got column, means row is 0, column is 6. When this configuration will happen, this is 0 0, this is 0 1, 0 2, 0 3, 0 4, 0 5, and 0 6. When I will move out of bound, in that case, what I have to do? I have to make column as 0 and row plus equals to 1. Why? Because I have to move to this point now. I have to move to this point. Initially, row is 0, column is 6. Okay. Now, what I want row as 1, column as 0. So you can see, if I add 1 in row, this will be achieved. If I put row, column equals to 0, this will be achieved. So what I will do, basically I will check if column is equals to array 0 dot size. If this is the case, in that case, make column equals to 0, increase the value of row. Now, if row is moved out of bound, that means if I am present at 0 1 2 3 4, so if I am present at 5 0, in that case you can say that I have traversed the whole character array. In this case, I have to check whether the answer which I am getting is correct or not. Okay. So in this case, we have to create one more function. So row is equals to array dot size. If this is the case, then you have to simply check if my answer valid. We have to create one more function which will check whether the configuration which I am getting is right or wrong. Configuration means basically the total number of plus in every row should be same. Total number of minus in every row and column should be same. Okay, so I have to check all those conditions. So top, left, right, bottom. Okay, I have to check all the conditions whether, let's say, top of 2 is equals to 3. That means at second column there should be 3 number of plus sign. Then I will check whether in my answer array I am having 3 number of plus or not. If this condition is false, in that case I have to simply return false. Understood? So these are the conditions which I am going to check. I am just giving quick overview. Okay, so in that case, return true, that yeah, I found the answer. After that, false. Okay, so now what are the functions which are left? My answer valid and is safe. So let's create is safe function firstly. So what I will do, I will create is safe function. So bool is safe. Okay, what are the arguments it is taking? Answer, top, left, right, bottom, row and column. So just copy this. right column, bottom. Okay, answer. Okay, that's good. I have copied it. It's say function. Basically, answer top, left, right, bottom. Sir, top, left, right, and bottom. No problem. After that, answer. Yeah. What is the row and column also? Row and column also. So basically, there are so many arguments now. So I just got confused. Row, column, and sign. Sign. Which symbol are you talking about? If you're talking about plus, then you have to check whether plus is safe on that index or not. Okay. So what are the cases? Firstly, we have to check whether it is getting repelled by any index or not. So if row, or you can simply say if answer of row minus 1 column, that means I am checking the current index with upper one. So if this is equals to sign, in that case simply return false. Return false because at just above index that same symbol is present. Okay, if answer of row column minus 1, this represents that at the just previous index, that symbol is present. So in this case also return false. And one more condition, row column plus 1, that means just after that index that symbol is present. In this case also return false. Okay, so these are the three cases for repel. Okay, now we have to check that if I put that symbol, that sign on that index, whether I am not exceeding the total limit of that symbol in that particular row and column. That means what I mean to say, basically, so if I am putting, let's say if I am putting plus here, okay, plus here in this character array, this is my character array, and if I decided that I want to put plus here, so what are the conditions I have to check? Whether top of 2, 0, 1, 2, top of 2 should be lesser than or equals to this number. Basically, top of any index represents that at most that amount of plus can be placed in that column. So I will check whether I am exceeding that limit or not. Okay, very easy. I am exceeding that limit or not. Okay, so I will check for basically firstly I will check whether the symbol is plus or not. If it is plus, then I have to check for top and left. If it is minus, then I have to check for bottom and right. Okay, so if sign is equals to plus, if it is plus, then I have to check for top and left. So to check in top, what I have to check? I have to check whether the total number of plus present in the particular column. In this column, the total number of plus should be lesser than the value of top of that column. That means, let's write it here, total number of plus in column should be less than top of column. Okay, this is the condition which we have to check. Okay, and exactly same for left also, but in that case we have to check for row. Okay, now what we have to find? We have to find total number of plus in that column. So we have to create one more function. This function will count the total number of plus present in that column. Okay, so int total, or you can say count in column. Okay, what this will check? Count in column. I am creating a function. This is the function name, and this will take answer, that column value, and that sign. Okay, now what I have to check? I have to check for row also. Exactly same thing. I have to check in row also. So count in row, answer, row, and sign. Okay, what this will return me? This will return me the total number of sign, that sign in the column and row. And if it is plus, then what I have to check? I have to check whether if top of that column is lesser than equals to count in column. If this is the case, I have to simply return false. And same thing for left also. Left of row is less than equals to count in row. If this is the case, in that case also I have to simply return false. Okay, and exactly same code for minus also, but you have to change the array. That is, left will be changed with right, top will be changed with bottom. So right here bottom and right here. Okay, if, after checking all the conditions, simply return true. Okay, so this is the step function. This is the step function. Now we have to create two more function: count in column, count in row. This is very easy. This is very easy. Count in column. So basically, we are provided with a column. We have to count we have to count the number of times in which that symbol occurs. So what I will do, I will create vector, not create, I will pass this as argument. Okay, vector of character, and here just write answer, and then column and character of sign. So what I have to check? I have to check, or I have to count the number of times that symbol occurred. So I will traverse the whole array, or not array, I will traverse the whole, you can say I will start from top and I will move till down. So I will travel all the rows, all the number of rows. So I is less than answer dot size. After that I plus plus. Then what I have to do? I have to simply check if answer of I comma column is equals to sign. If this is the case, you have to simply increase the value of counter. Very easy. And after, return me the value of count. Okay, now let's copy this code. Exactly same code for row also, but in that case you have to traverse over columns. So count in row, vector answer, here you have to write row, counter 0, answer of 0 dot size to traverse over columns. And here you have to write I, and here you have to write row. Okay, and now exactly same code. Now let's see, right here rows, because the name of function is exactly same now, so this will throw us error. Okay, now we have created step function, we have created count in column, we have created count in row. Okay, now let's discuss one more thing. I want to discuss one more thing. Basically, as I mentioned, move to this. Yeah. So as I mentioned, that top, leave it. Okay. So top of any index, let's say 1. This can contain two type of values: -1 or any other index value. Okay. So what -1 represents? -1 represents that it can contain any number of plus in that particular column. It can contain any number of plus in first column. Okay. So let's say if the value is -1, and if I am checking for top column equals to, I am checking this condition. Okay, I am checking this condition, and the value of top of 1 is -1. So in that case, we are having infinite number of supply of plus, and we are checking whether the value is lesser than count or not. So basically, what I mean to say, let's move to empty space. Okay, let's say the value of top of 3 is 2, top of 1 is -1. Okay, these are the two cases. Now what you did, you find the count of plus in third column. You find it. Let's say you found it 1. You decided that you can put it. Yes, you put it. Okay, what is the condition? You have checked top 3 is lesser than you can say count. Okay, so you check this and you find that this is correct. Now I am going to put it. Okay, now if this I'm talking about this condition. Now let's say top one in the first row, in first column, you found 5 number of plus. You found 5 number of 1 in this plus, minus, 3 number of plus. Okay, you found 3 number of plus. So if you will check -1 with 3, so -1 is lesser than 3. So it will say us that yeah, you cannot put any more plus in this case, but we can put any number of plus. So what I mean to say, basically we have to check that whether top of column is not equals to -1, because -1 say that I can put any number of plus, So I cannot compare -1 with any number. Basically, I don't want to compare -1 with any number. Okay, exactly same thing. Exactly same thing. I will check for left also. Left of row should not be equals to -1. Okay, and exactly same thing here. Bottom of column should not be equals to minus. Okay, and here also RHST of row should not be equals to minus. These are the cases which you have to follow. Now, what left? What left? What left? Oh yeah, this function. My answer valid. So we have to create one more function. In this case, simply you have to check whether let's say top of 0 is 5. So you have to check whether in 0th column total number of plus should be equals to 5. If it is not equals to 5, then simply return. Same for left, bottom and right. Exactly same. So this is very easy function. Is my answer. Achha, okay. My answer valid. Okay, this is the name of the function. Okay, what are the arguments? Answer. Just copy. Just copy. Okay. So just copy this, paste it here, and write here answer. Okay. Now what we have to check? We have to check in top also, left also, bottom also, and right also, that the total number of count is equals to that value or not. So 4 into I equals to 0, I is less than top dot size I plus plus. I am checking in top, so I have to find the total number of plus present in that particular column. So what I will do, I will find the count in column, very easy, equals to count in column, and then I have to pass that particular index value. So answer, and let me see what is the answer. Yeah, answer I and plus, because if I'm talking about top, then top is storing the values for plus. So if count in column is not equals to top of I, if this is the case, you have to simply return that yeah, the total number which I require is not fulfilled. So in this case, you have to simply return false. Now just copy this for bottom also. So bottom dot size, easy. Here you have to write minus. Okay, leave it. You have to write minus. Okay, else everything is same. Right here, bottom, no problem. Now for left also you have to check in row and in row. Okay, exactly same code. Okay, the code is very lengthy. I know the code is very lengthy. No problem. We have to do this now. We have to do this. So rows is not equals to you can say left I. In this case, you have to return. Just copy this and paste this for right. Paste. Okay, right dot size. After that, rows, row answer minus. Here you have to write rows, right I, and after all these conditions, simply return true. Okay, and here also you have to check whether count in rows, or you can say if left I is not equals to -1. In this case also, because we don't want to compare -1 with any number. We don't want to compare. Okay, so exactly the same thing you have to write for every place -1, and here you have to write bottom of I should not be equals to -1, and here also left. Okay, I written here. So here of I should not be equals to -1. Okay, so this is the whole code basically. Let's see how many errors we got in 14th line. Okay, so the code is lengthy, so we are going to get so many errors. Okay, no problem. So character, answer, column, and character sign. Okay, no problem. Count in column function was not declared column. Okay, so int. Let's see what's the problem. Basically counter answer dot size, no problem. I column equals to sign, then counter should be. Oh, what's the problem, bro? Basically here we are doing mistake SIGN. Okay, so we are doing mistake in the spelling of sign. Let's run this code again. Yeah, now our code is accepted. So basically what we are doing, let me give the quick overview. Basically we are having four values L, B, T and R. LR represents left to right, TV represents top to bottom. Okay, so if we are moving left to right, then we have to make two choices. Either we can put plus minus or minus plus. The configuration of magnet can be plus minus or minus plus. Okay, now for TB also, we can make two choices, plus minus, minus plus. But when we are taking L into consideration, we have to make our next call for column plus 2. And when we are taking T into consideration, we have to make our next call for column plus 1. Okay, now for every plus and minus, we have to check whether that position is safe or not. So to check, what we are checking, whether it is getting repelled by any other magnet, or when we are checking that the count of that particular column should not exceed the particular value of that array. Okay, now after this, we are checking whether the final answer which we got, the final array, the final matrix which we got, is perfect or not. It should be perfect, means let's say if top of 2 is 3, then the at second column of our array there should be 3 number of plus sign. So we are checking whether we are having exactly same number of plus or not. Same for left, same for right, same for bottom. Okay, so this question is a little bit tricky but not hard. This question is lengthy but not hard. Okay, so I hope you guys understood what we are doing today. If you like this video, please like, share and subscribe to Pepcoding. Okay, so we will meet in the next video. Till then, bye.